Hi, thank you for listening to ISACA podcast. My name is Dio Joe, Principal Research Analyst for Emerging Technologies at ISACA. Today I am joined by Advait Patel, a Senior Site Reliability Engineer at Broadcom. In this episode, we're going to be talking about practical security lessons around containers, as well as actionable security tips, and also how AI can actually help to improve container security. Thank you for joining us. So, Patel, traditionally, container scanning has become a really standard security practice. Yet, vulnerabilities and misconfigurations still make their way into production. Why do you think existing scanning tools miss so many critical issues? And what blind spots should organizations be paying more attention to?
Yeah, sure. Thank you so much, Handai, for having me. So the problem that the existing container security tools are only focusing on one slice of the issue and not the entire aspect, not in the entire pie of the problem, right? For example, there are tons and tons of great container security tools out there which scans your code infrastructure, which scans your product, which scans your which scans your entire environment and gives you a list, a huge list with the findings, with the CVE, with the issues that they flags and etc. Right, but it is just one part of the problem. They don't focus on the remediation part. They don't focus on the because, for example, findings, if you compare the findings from last 5 years or maybe 10, 15 years, they are not the same as what we are seeing today, right? In the world of LLMs, in the world of AI, it is also evolving, right? So those findings needs to be changed, those findings also needs to be challenged, and that is where the existing container security tools are lacking. For example, the tools are only focusing on CVEs. They are only they have a bunch of rigid format, rigid structure, and they are also only focusing on those CVE lists. But what happens outside the CVEs? What are some of the misconfigurations? What are some of the best practices that the containers are not following? Right. So those container security tools are only focusing on predefined set of rules, but they are not thinking outside the list. So that is where we are lacking behind, and that is where I think there should be something that is covering these aspects which the existing tool sets are not covering, and that's what the industry is lacking right now.
Interesting. Thank you for that. And just to understand more on a broader scale around specific use case, what are some of the most common insecure Dockerfile patterns or embedded secrets and misconfiguration mistakes you've encountered over the years during your professional career, and why are they so frequently overlooked?
Sure. So this is a very good question. This is the very basic question that I get. I like, people ask me every time whenever I go to conferences. Doesn't matter if it is an industrial or academic conferences, but this is the question I or anyone would frequently hear. Right. So as a Docker captain myself, and also being in this working with this Docker technology for past couple of maybe past 3 to 4 years. These are some of the things that I have seen which are very common, and which are like, for example, out of 100 Docker files or after 100 Docker images, if you scan, doesn't matter which tool that you are using, doesn't matter if it is AI powered tool or non AI powered tool, right? But for example, containers, most majority of the containers are running as root. So you are literally giving a key to your container so that it can do anything. Just imagine something, an attacker comes into the picture and taking advantage of this root privilege escalation, right? So now you are giving your container free hand, and if it goes to an attacker hand, then they can do anything. They won't just enter into into your product or infrastructure, but they will move sideways. Now they have the now it's not about container. They are literally hijacking your entire product, and from product to network, and then host machines, and then security and database, right? So this is affecting everything. like when you tell your developer that do not use or do not give root level permissions to your container, it sounds very straightforward, very simple. But the results, when they don't follow this advice, it will be very much difficult. The second thing that is very common that I have seen is hard coded secrets. We like usually we don't like we think that okay, I am putting this secret, maybe a temporary database password or temporary credentials, and we are thinking that oh, these are not visible in my Docker file, but these are baked into my Docker image, right? So this is what we usually think. And when we think that okay, these secrets are not being visible in my Docker file, these secrets are in my Docker image, so no one will see it, no one will able to use them. But that is a false misconception, right? Because if you hard code your secret, doesn't matter if it is in Docker file, Docker image, it will be hard coded, it will be visible to attackers, it will be accessible to any bad entities, right? And once they have their secrets, for example your database password, they can have your entire they can capture entire database copy, they can have your sensitive information, and now you are dealing with completely different issue. So that is second common mistake that I have been seeing. The third common mistake is like the base image that your container is using at the foundation layer, right? For example, you are using Python maybe 2.7, right? But you are not updating your package, you are not updating your base image. So now you are building your entire stack on something which was already vulnerable before you even started, right? So that
Right.
is the third fundamental mistakes that I would say. And the last one would be like old vulnerable libraries. You are using something that was created years ago, you are using something that was not updated months ago, right? So that library is not only affecting that component, but it is increasing the blast radius. For example, that library is touching X, Y, and Z component. Those X, Y, and Z components are touching A, B, and C components. So now that blast radius is increasing. Now that one vulnerable library is affecting hundreds of other components, hundreds of other sub libraries, right? So people don't think in this way. People say, oh, just one library, I will fix it later, or I will fix it after I come back from vacation, or after I come back from these high prioritized items. And what bad activity this library would do. So things like this, those, I think these are the four aspects that I have seen in my experience. Whenever I talk to or whoever I talk to in these conferences, people are making this silly mistakes, and these are the foundational layer problems that needs to be addressed whenever we talk about container security.
Thank you for that, Advait. Just to understand, so out of the four instances of different security concerns around Dockerfile that you mentioned, which one do you think it's the most, immediate, needs the most immediate attention in terms of actually closing that vulnerability gap?
Actually, they out of 100, these are the top four items that need immediate attention. For example, if you are asking me, okay, I want to go ahead and start looking at my container security, and I want to improve my container security, what would be the top things that I would look at? Those are the four items. But if you ask me, out of those four items, something that comes as highest priority would be the root level permission. Because vul- having a vulnerable library package can be dealt with, having a hard coded secret can be dealt with. You can easily swap your secret, you can easily update your secret, you can update the library version if it is vulnerable, you can update your base level image if it is vulnerable, or if it has findings, or if it is affected, right? But having root level permission is the most dangerous weapon that you are giving attacker access to, right? Just
Right.
imagine that you have your entire infrastructure, and someone with bad intentions has root level permissions that they can do anything that they want, they can take anything that they want, they can perform anything that they want. It is not affecting your container, it is affecting your company, the team, the product, and eventually the customers. So
Right.
if you were to ask me about having one particular problem that needs to be addressed almost immediately, that would be restricting the root level permissions, because sometimes we don't realize that our containers actually don't need extra permissions that we think that they need, right? So starting with this root level permission would be the really good step to start with.
Fantastic. Thank you for that. No, I read that you created DockSec to address gaps in traditional container security approaches. If you can just give us a clue into what inspired you to build the tool, and how does leveraging AI enable DockSec to identify risks that are significant, that typically signature-based scanners often fail to detect?
Yeah, sure. So to be honest, frankly speaking, DocSec was created out of frustration, because I come from software engineering background, and due to the versatility of our industry, I also wear security engineer's hat, right? So like, out of all these years, I was trying to bridge a gap between security engineers versus software engineers. Like, both of their jobs are different, but towards the same goal, towards the same destiny. Like, software engineers want to make their product secure and want to fix solutions, want to fix their libraries, want to fix their code. And security engineers want to help software engineers to make the product, or make the overall security of the product more secure, right? So they want to help both of themselves hand in hand, but it's just that it doesn't happen. For example, security engineer's job is to scan the infrastructure, to scan the product, to scan the architecture, right? And whatever that they find, they handed this report to the software engineers, saying that okay, these are the reports, and it those reports have findings, those reports have CVs, those reports have like bad configurations or bad practices. Then you guys should fix it in order to make the entire infrastructure secure. So both of them have good intentions, both of them have want to fix stuff, right? But imagine yourself going through these reports. Each report has hundreds of findings, and now you are getting overwhelmed. Oh god, I have one report to fix which has 200 findings. I have couple of reports to fix which are couple of hundreds of findings, right? Now you are buried under the findings. Now you don't know where to start, you don't know how to get started, you don't know which one you need to pick up first, right? So now those findings are getting buried under piles of reports and findings, right? And then next month comes in. Next month, again, the cycle repeats. Security engineer scans the infrastructure, generates the reports, sends it to the development team, hoping that they will fix it. And this cycle gets repeats, and it's like literally never-ending process. So this is the gap. Out of frustration, this is the gap that actually motivated me to build something that works in both of that direction, that works for security engineer, works for software engineers. So that is why I created a DockSec. So basically, DockSec is a tool. It's an OS adopted open source tool, which is AI analyzer container security tool, right? So what it does is, it the main goal of DockSec is to not replace your existing container security tools. The motto is not to replace your existing tool set, but it is to help you on improving your posture, right? So now what it does is, whenever a security engineer scans, or whenever your infrastructure is being scanned, DockSec is sitting on top of it. It says, okay, after scanning your infrastructure, I found these 200 findings. I found these 200 vulnerabilities. But wait, you don't need to get overwhelmed. Out of these 200 vulnerabilities, you only need to address these five, which are very critical, which are like needs to be addressed very quickly. And rest 195 can be done later, because they have less priority items, right? So now software engineer, when they see the report, they don't need to get overwhelmed, they don't need to worry about those rest 195 findings, right? They only need to focus on those five findings, right? So they can get those things done easily in no time, and then when time permits, they can focus on the list prioritized items later on, right?
Right.
So this way it's a win-win situation for both of them. Win situation for security engineer is like the critical findings which were not addressed before now being addressed, and for security for software engineer, they now know, okay, what needs to be addressed or what needs to be fixed immediately and what can be done later. So it's a win-win situation for both of them. Now for example, there are some occasions where security engineer need to take action, but because of they did not create this code, they don't know where to make this change, how to
Right.
make this change, right? Because this goes into production level, and this goes into production environment, right? And no one would trust anyone to touch the production environment if you don't know the context, if you don't know the environment very well, right? So
Right.
DockSec also helps you to fix the finding by telling you where to go, which file to edit, and in which file, which line number, like with line number, what to edit and how to modify. For example, if your file is containing hundreds of line and maybe line number 71 has some hard coded secret, so that DocSec will tell you, okay, go to line number 71 in xyz.java file and fix this. So now security engineer doesn't need to know the context of the entire product. They just need to go to that particular file and they just need to fix it. So this is kind of removing the dependency between security engineers and software engineers. So now security engineers can also fix and resolve and remediate those findings, right? So
Right.
this is the exact gap DocSec is trying to solve. And getting the adoption from OS is a big boost, because OS community is using it. I have a couple of production companies, customers which are using in their CI/CD pipelines. I have right now DocSec as about last time when I checked, it had about 21,000 downloads on official PyPI package, and
Wow.
the repository already had about 420 plus GitHub stars. So this along everything shows that it is getting momentum, it is getting traction from the community. And the problem which I thought only I am facing is not true, but the industry is facing it, and I have been seeing this with these numbers, with the usage number of DocSec. So this is what actually DocSec does, and what DocSec is.
Awesome. That is a great explanation. Thank you for that, Advait.
Mhm.
Um, yeah, so AI, as we all know, is one of the hottest topics in cybersecurity today. But separating real value from marketing hype can be quite challenging. Where do you see AI genuinely improving security outcomes today? And what limitations should security leaders and practitioners keep in mind when adopting AI-powered security tools?
Okay. So let me tell you one fact, that AI is here to stay. Couple of years ago, everyone was thinking, oh, it will just come and it will just go, right? But no, I have been seeing AI running into the production environments, AI agents doing things for betterment into the production environment. Also, on the other side, I have seen AI agents messing up into the real world architecture into the production environment. So just like any other technology, AI also has two sides. One is good, one is bad. It depends on how you are using AI, it depends on what you are using AI for, and it depends on what sort of things that you are looking from AI. For example, AI is doing tremendous job when you are asking it to find the pattern, like pattern matching, like finding the sequence, finding something. For example, okay, uh, like for example, hard coded secrets, right? That out of thousands of lines of code, a person, an engineer, has to go through each and every line manually to find out the bad practices, to find out like okay, where are the hard coded secrets, where are some things is missing, right? So that is where AI is very useful. That is where you can just use AI to help you as an assistant, where you are the sole proprietor of the thing, where you are the sole proprietor of the task, and you are using AI as an to assist you to achieve something, right? So that is where AI is doing fabulous job, and that is where you should use AI. Doesn't matter if it is for security architecture, doesn't matter if it is for any other task. So that is the good side. But now coming to the flip side, so things like running your AI in production and giving it root level permission, running or letting your AI agent making tasks, making decisions, making API calls without your oversight, without your permission, without your approval, and letting it just run stuff randomly. That is the bad part. That is where the industry is saying the shift right problem, right? That is where industry is saying, oh, AI is not, AI is doing no good for us, because you are not controlling AI. For example, we are from security and compliance area, right? So we also need to make sure that our products are compliant. We also need to make sure that our products are secure. So when you appear into the audit, and when an auditor asks you about the specific call that that your AI agent made, and if you give answer, if you say, oh, it depends on LLM that it is using, then you are being flagged, then you are being, then they will definitely give you a finding saying that you are not using AI in a right way. But if you have an answer about what sort of controls that you have your on your AI agents, what sort of controls that you have on your AI technology, that will make you fully compliant, that will make you fully secure. Because we are not here to, we are not here to let AI replace us, but we are here to use AI as an assistant rather than as an owner, or rather than as a boss. We should tell AI what to do instead of the other way around. So that is where we need to set up guardrails, we need to set up controls, we need to set up least privilege model, least privilege action as much as we can. We need to educate ourselves, because we think that AI agents can go rogue only at LLM layer, only at someone when someone gives a fault or malicious prompt. That is when AI gets malicious. It is a false misconception. It's a misconception, because AI gets malicious when it attacks the tools, when it reaches your tools, when it reaches your database, right? So these are some of the things that we need to educate ourselves. We also need to educate our teams, and then with this knowledge, with this guardrails, we need to implement in our environment, and then we can trust AI. We can trust AI to make those things easier for us, not letting it make the business critical decision for us. For example, delete production database, or maybe delete something which it never intended to, right? Because AI, it will lie confidently, and it will tell you, oh, this is false, and those findings are completely false positive, right? So AI with human control is what we need.
Awesome. Yeah, absolutely relatable. Thank you for that. Now, before we wrap up, is there anything else that you want to share with our audience that we haven't had a chance to cover yet today?
Sure. So, like, even today, even when we talk about container security, everyone just hear stuff, but they don't pay much attention to, right? Because everyone thinks that containers are microservices architecture. Like, containers is very small, it only has some software underneath it which is running. But we also need to think that that software has your entire infrastructure, that software has your critical business component, that is what it is running, right? So just imagine, compromising a container is not compromising single container, but it is compromising the, it is opening the door to your infrastructure. So rather than ignoring it, we need to start implementing it rather than ignoring those early signs. We need to make sure that we have the security controls in place. As I said above, as I said earlier, those four things, those four guardrails, like not letting your containers run as a root level user. Do not include any hard coded secrets. Use Vault, use any secret management tools. Doesn't matter if it is open source, doesn't matter if it is vendor proprietary. Use That's the right investment. Use proper updated base image in your containers, and frequently update libraries that you are using in containers. If you don't do anything, if you don't have frequency, if you don't have capacity or bandwidth to do anything, just do these four things and you will be secure. Trust AI only to do repetitive tasks, only to find the patterns, only to find the sequences in your code, in your infrastructure, in your security posture. Do not let AI take over. Do not let AI overtake your system. Do not let AI make decisions out of hallucination. Implement proper guardrails. Use policy access control. Doesn't matter if they are open policy access, doesn't matter if they are custom policies, but use some sort of control over your AI and it will do good for you. Because in this time we are continuously evolving. Today we are talking about this aspect, tomorrow we would be talking about something else. The day after tomorrow we would be talking about some completely different aspect of the posture, right? So we need to evolve with AI. We need to evolve around AI, and we need to make sure that whatever changes are happening in our production environment, everything has to go through an experience manual process rather than having black box kind of thing. So those are the some of the things that we need to take care of. And also tools like DockSec are here to help community, are here to help both security engineers as well as software engineers, are here to not replace your existing tools, but here to enhance your existing tools, here to enhance your experience for the security industry, for the security posture of the product, right? So let's take one step at a time, and let's secure one container at a time. I think that would be all.
Awesome. Well, it's been a pleasure talking to you today, Advait. Thank you so much for your time. That's all we have time for today. Thank you again.
Likewise, thank you so much for having me. Thank you so much.